Hi, everyone. For today's class, we'll talk about statistical computations part 1 because there's a part 2 of this. No? So as the term implies, computations. No? Though computations are not the only focus here. No? We will do some interpretations also. No? But the way the slides are presented, the focus is more on the computations. But again, this is data analysis. That's why I have to remind you that no. Okay, no. We'll do some interpretations as well. Okay. I think this is the start, as I mentioned to you, for the next 5 weeks. No, we'll be focusing on statistics. No, on statistics, and this is the first lesson regarding that. No. So when we say statistics, we usually refer to two branches. There's what you call descriptive statistics and inferential statistics. No. So as the term implies, or as the phrase implies, descriptive statistics, so the focus is on description. The other one, inferential statistics, the focus is more on prediction or the inference. No? So what do you describe? What do you infer? The data, the big data that we discussed last time. No? The large data. But again, here, class, in the PowerPoint, I will just use small data. No? Because we will do computations. That's the reason. But again, in reality, in a practical setting or in a work setting, professional setting, you deal with big data, the big data that we talked about last lesson, large data. Okay, so whereas here, class, computation, manual computation. So it's hard to do if it's a big data, right? Large data. That's why I will mention also about software program, because in a work setting, professional setting, practical setting, we don't do it manually. We don't do the computations manually. We use software. We use program. No? That's why computer science is related to data analysis. No, it's not data analysis as we learned, but we can use the tools, no, or the skills that we develop in computer science, no, for data analysis, no. Particularly on that part of the computation, computational part. Okay, so the statistical part, more on, there's computation. However, there's this focus on the analysis. No, when you talk of statistics, there's this focus on analysis. No, okay, but I'm not saying for computer science there's no analysis. It's just that that's why computer science, right? That's why there's some misconception of more of computations. No, in a way, it's kind of correct because that's what your program. No, you want to ease the computation. No, that's why you have this program and algorithm. But of course, it's not just I also disagree that it's just computation, because when you do algorithm, you have to analyze, right? You need a skill there. No. If you and usually in computer science, you use algorithms, right? And when you create algorithms, programs, you do analysis. So that's why I cannot just say it's just computational, no? Okay. In fact, it is because of the algorithm, the program, it not simplifies, but it helps you to compute. That's why later we will use that, no? That program, a certain program. No, probably created by the computer scientist. No, anyway, so again, as going back, so we have descriptive statistics and then inferential statistics. No, so so descriptive statistics, you describe your data, description of your data, whereas the inferential statistics are the inference or prediction of what you can get from your data, no? From your big data. What prediction can you arrive? What inference can you arrive based on your big data? Okay. So for this lesson, class, the focus is on descriptive statistics, no? Description of your data, your big data, large data. But there's an irony because what we're going to use here is small data only, no? Okay. So anyway, I'll tell you the reason why later. So for this descriptive statistics, we have 3 measures that we will discuss today, and these are the 3 major topics, no, for this lesson. So these 3 measures of descriptive statistics are this: measures of central tendency, measures of variation, measures of relative position. So we will use these measures to describe our data. So question is, how do these measures, for example, central tendency, describe your data? How do these measures of variation describe your data? How do these measures of relative position describe your data? That's what we're going to learn today. Okay, let's dive into the first part, the measures of central tendency. So for the measures of central tendency, we will use three measures to describe our data. But again, the question is, how do we use these three measures, the mean, median, mode, in describing your data? So as the phrase implies, central tendency, center. So we will describe your data in terms of its center by computing a single value. So mean is a single value, median is a single value, mode is a single value, which will describe the center of your data. That's why this is also called measures of central location. Okay. So let's dive into the first one, the mean. So I think you're familiar with this. This is the average class, not the average. Mean is the sum of the numbers divided by n. So you're very familiar with this. If you'll notice, again, the data is not big, no? Because the reason is, this is that we're focusing on the statistical computation, no? Computation, statistical computation. Okay. So again, don't misunderstand that, because if you look at the data, there are no units, no? No units, and then no context, no? But in reality, or in actual setting, it has context, meaning it should have units, no? It should have units. I have to tell you that, so that you may not misunderstand that we're after only the computation. No. Yeah, you may think that the focus for today's lesson is computation, but still, I will mention some interpretations. That is why it's still above the computation, no? Because you might misunderstand the name or the title of this of the lesson, no? Statistical computations. No, we will go beyond the computations. No, we will go beyond the computations. So that's very important, huh? The context. Okay, so now these are your data values representing x sub I for I equals 1, 2, 3, 4, 5, 6 respectively. So meaning we let x sub 1 equals 92, x sub 2 equals 84, and so on and so forth. Okay, so we have this formula. By the way, this is sub I, x sub I, no? Summation of x sub I divided by n. Simple as that. So just add all of them, divided by 6, you get the mean of the data. Now, if you will look at this class, this is like small data, and then also raw data, and ungrouped data. Ungrouped. Especially if you see a big data, you will really see, no, it's ungrouped data or unorganized data. Unorganized, meaning not organized data. For now, you can see it like, you can not differentiate, no, the group data from ungrouped data, because it's just small data. But if you look at, if you have a big data and then no organization, you will really, that's really ungrouped data. Okay, or an unorganized data or raw data. Because there's another kind of data which we call group data. Group data. And to do that, we use a table which we call the frequency distribution table, which we will tackle in the next lesson. No, that frequency distribution table. But I'll give you examples later in the website. No, but we will discuss more about it in the next lesson. So if it's in a table, so it's a group data. Okay, in a way, it's already grouped. We group the data, no, using a table. So you can appreciate, no? Now you can see the distinction if you have a big data, no? And group data without organization, just raw data, only a list of all data values. That's like this, list only, but a lot of them, probably 1 million. And then distinguish it from a table. Now you can appreciate. Now you can see the difference. Now it's organized if it's on the table. Okay. So why did I mention this? Because we have a corresponding formula of getting the mean of group data. Not this formula. Okay. We have a corresponding formula for that. And later, if we have time, I'll show you a website now regarding the formula of that, of the mean of group data. This one is the mean for ungrouped data. So class, this is the first measure of central tendency, which is the mean. So let's go to the next one. The next measure of central tendency, which is the median. So median of a ranked list of n numbers is the middle number if n is odd, the mean of the two middle numbers if n is even. No? So so going back to the mean class, so we use the mean where we get a single value to describe your data in terms of its center. So you may say that this data value describes the center of your data. And then the median also, no? Will get a single value which describes the center of your data. And similarly for the mode. And that's the third measure of central tendency. Okay. Now I want you to focus your attention on the small n. No? When you say small n, we refer to the sample size. If it's capital N, we refer to the population size. I think I mentioned to you before about sample and population, because possible that your population is really come from a big data. No? You have like a big data. So when you gather data, if not impossible, difficult, no, to gather data, to collect data. That's why you just consider sample. And there are ways of collecting, getting sample from your population. Okay, which I will not discuss to you anymore, but I hope that you will recall what you learned in high school regarding that, if you learn about it. Otherwise, you have to learn about it. Now you have to do a research about that, and that's why we have here small n, which is the sample size. But we can talk of median of the population. No? That's also possible, median of the population, because possible that your population is manageable, meaning you can manage to gather data from your population because it's not really that large. No, can be small, just enough to, not really small, but enough for you to manage it in terms of money, in terms of effort. No, okay. But again, if there's problem regarding gathering of data, then it's better to consider the sample and refer the size of the sample as small n. Okay, so. And this is also a way to describe, we'll get a single value here to describe the center of our data. Okay, so let's have an example. So again, without context, without unit, so just to focus on the computation. But again, in actual setting, this has units, it has context. Okay, so I keep repeating that so that you won't keep loose of the track of the focus, And besides this data analysis, in reality, we'll not be dealing with small data, with large data. Okay? Okay, so here, class, we have odd. So I think you know what to do now. Rank data, so arrange from lowest to highest. And then the middle, just the middle. Or if you want, because problem here, if it's not as simple as 7, you can apply this formula, n divided by 2, then round it off. Because problem is if you have like 100, so 100 divided by 250, right? I'm sorry, odd, right? 101 divided by 2, 50.5. So the 51st. For this one, 7 divided by 2, 3.5. The fourth. That's why the median is the 9. Okay. But again, class, this is ungrouped data, Ungrouped data. So there's like a corresponding formula for the ungrouped data, just like the mean, the one I mentioned to you regarding the mean of group data. So hopefully later in the website, we'll see the formula for the median of group data. Okay. Actually, class, I will also, that's why I shared to you the Excel file, because later we will use that to compute for some of these measures, but not all of them, because probably we lack time to do that. But some of these measures that in actual or in a real setting or in a professional setting, work setting, we don't really use these formulas already, or even the formula for the group data. We'll just use the software or the program. As I mentioned, that's the use of the program to ease the computation. But important also that you experience how to compute, so that you'll be able to appreciate, you'll be able to appreciate technology, okay, or that software. So in a later class, it's the Excel file, that we will use. But there are other softwares other than the Excel file, when we want to get, when we want to compute for these measures, we want to compute for these measures, not only the Excel file. Okay, not only Excel file. Okay, how about if n is even? So again, you can apply that formula. N divided by 2, 3. So that means the third and the fourth, get the average of the third and the fourth. So 77 plus 89 divided by 2, that's 83. Okay, so that is your median. Okay, so because in the previous slide, it's only mentioned descriptively, no formula, but you can use that formula. No? Use that formula, especially if it's not as small as this, no? Small as this. Okay. Actually, class, for the group data, there's no distinction, no? Whether it's if n is even or odd, no? For the group data. Okay. And we will base it on the group frequency distribution table, on the frequency distribution table, no? The one I mentioned to you a while ago. Unlike this one, class, you base it on the raw data or ungrouped data when you get the mean and median. Okay. Similarly, for the next measure of central tendency, which is the mode, you also base it on the, when you want to get the mode, you base it on this, no? If it's ungrouped data or raw data. But if you have the group data, to get the mode, you base it on the group frequency distribution table, which I will discuss to you next lesson, no? The table. But we will see an example of this later in the website, this group frequency distribution table, where we base the formula in the computation of the mode or the mean or the median. Okay, later for the group data. Okay, and that's useful for big data, no? But again, as I mentioned, we don't really use this anymore, no? These two. The formula for the group data, the formula for the ungrouped data, but we will just use the software, the program, okay, to get this. Later we'll discuss that, the disadvantage of using these formulas also. Okay, but I think right now you can see the disadvantage. No? Okay. The advantage I already mentioned to you, so that you can appreciate the technology better, that you know also. No, that's why now we're reviewing, no, how to get this and how to compute for this measure, so that you will be able to appreciate, no, the technology or the program used to compute for these measures. Okay, class. So I think that's it for the first part, for the measures of central tendencies. So you can use one of these three, depending on your study, depending on your question. Remember, in the data analysis, remember when we talk about the steps in scientific method, like you have a question, you have a topic, you have a question, and then you can have a hypothesis also to answer the question, and then you gather your data, and then after gathering your data, you can use the frequency distribution table. Okay, it depends on the size of your data, or you can use this is one, or the software, the program, no, for your for research, for example, for your research, no. Sometimes for research, since you're college, you can use this one, the computational part. Now you can show also, no, and then contrast it with the software. No, you can present all those, no, all those three in your research. But in a that's in a college setting, no. But in a work setting, we don't really use this anymore, no. Just the program or just the software. Okay. So as I mentioned, the measure of central tendency that we will use to describe the center of your data will depend on the study, or the question. So there are times mode is better than the others, or the best among the three, or the median, no. But among the three class, really, the most frequently used is the mean, most frequently used. But again, as I mentioned, it depends also on the study. Okay, but the most frequently used is mean. Why? Why do you think mean is the most frequently used, class? Because remember, these measures of central tendency give you only single value, just one value, like this: 15. What else? 83. 9. It's a single value. But this one already talks about your data, no? About your data. And what if you have like a big data, not only this few? So what is the disadvantage of using mode? The disadvantage is that, especially for big data, you're talking of single value, but representing the whole data, but you know that this one, you only choose it among those data values, right? The others have no influence, right, to this value. Okay? So this is the mode, right? The number that occurs most frequently. That occurs most frequently. So I think no need for me to explain this more, right? That's easy to understand, right? But you have to arrange it first, no? You have to arrange it first. That's why you get here 15. Okay? So you notice this one, just single value. Just single value. But single value, then you're talking of the whole data. But this single value is not influenced by the other values. By the way, class, if you have one mode, you can say that this is unimodal. Your data is unimodal. You can have two modes there. For example, if you have 21 here, 21. So you will have two modes, right? So there, what do you have now? Two modes. That's why your data is bimodal. You can say that your data is bimodal. So if you have three modes, I think you know already, it's trimodal. Okay, it's possible for you to have more than. But still, class, even though you have one mode, two mode, three modes, these modes are not influenced by the others, no? By the others. But there are times this is best or better depending on the study. But among the three, as I mentioned, it's the mean because of that property, no? That property wherein this one is only influenced, it's not influenced by the others. How about the median, class? Similar, no? Similar. 83 influenced by the two, but not influenced by the other values. But again, there are times median is better, best among the three, depending on the study. But again, the most frequently used is the mean. I think you know already the answer. Why? Why the mean, right? Why the mean is the most frequently used? Because as obviously in the formula, to get the mean, all the values influence the mean in the computation, right? That's why in most of the studies, we use the mean, no? We rarely see the median and the mode. But again, in some studies, we can see them. But most of the studies, research, most of the time that we see is the mean. If you want to describe the center of your data, because of that property that all the values contribute to this single value. All your data values contribute to this single value. But there's one disadvantage. Do you know what? Do you know what is the disadvantage? The extreme values. What if you have, for example, in your data, possible for you, example only, no? It depends on the context. In the context, you're allowed to have 1 million, for example. In your study, allows you to have 1 million. Then that 1 million will affect this. So in that aspect, it's not anymore a best measure, or a better measure of central tendency, or to describe the center of your data. Probably the others will be better. Okay, so that's the disadvantage if you have extreme values. Okay, so that's the first part, class. That's the first part. No, so this is the second part. To describe, if you want to describe your data, the measures of variation. Okay, so what do these measures of variation, or how do these measures of variation describe your data? So if the measures of central tendency describe your data in terms of its center, the measures of variation describe your data in terms of the dispersion or the spread of your data. That's why it's variation or variability of your data. And for this one, class, to do that, we have three measures. Just like in the first part, we have three. But again, these are not the only three measures. No, these are not the only three measures of variation, but these are the main: the range, standard deviation, and variance. No. If you will look at the measures of central tendency, the simplest there is the simplest is the mode, right? The mode. Here, class, it's the range. No. It's because it's just okay. Yeah, by the way, measures of variation can also be called measures of spread or dispersion. As I mentioned, no? Spread or dispersion. Okay, range is the difference between the highest and the lowest value. No, that's why it's the simplest. No, all you have to do, get the difference of the highest and the lowest. So better to arrange them so that it's easy to identify the highest and the lowest and get the difference. So that's your range. So the range of your data values is 7, something like that. Especially if you know the interval 14 to 21, so you know that your data values are within that interval. and with a range of 7. But again, you notice if you want to talk of the spread or the measure of your data, it's not yeah, in a way it talks about spread, but not that that accurate, no? Not that accurate. Okay, if you want to talk about the spread of your data, the range is not that accurate, but it tells you a little about it, no, already. So, but there's another measure which is better than the range, no, which is this one, the standard deviation. Okay, standard deviation. Okay, so we can denote standard deviation as S or mu, because we can talk of sample standard deviation or population standard deviation. Actually, in the first part class, we can also talk of that, no? Sample mean, population mean. Sample median, population median. Okay, and then sample mode, population mode. Because as I mentioned, when you say sample mode, you get this mode from the sample, or you get the mean from the sample, or the median from the sample, or the range from the sample, or the standard deviation from the sample. So when you say population, population mean, population median, population mode, population range, population standard deviation, you get this. You get these measures from the population. That's why it's called like that now. And when we denote it for the standard deviation, S the sample, and then the population mu. I'm sorry, it's not mu plus, huh? I'll replace this by sigma. Sigma, no? Replace this one by sigma. The mu is the mean, population mean, no? Actually corrected this already. I don't know how come it's not still corrected. Anyway, it's a typographical error. So anyway, what's the standard deviation? It's the amount by which each individual value, the x sub I, deviates from the mean, which we denote as this or this, because if you want sample mean, we denote it as this. If we want population mean, we denote it as this. Okay, so you notice, class, if you want to refer to the population parameters, such as the this one, the mean or the standard deviation, we use Greek letters, no? We use the Greek letters. Whereas for the sample, we use the letters from the English alphabet, such as the small s or the x. This, it's only to distinguish, no, population parameters from the statistics. When you say statistics, I'm referring to the small s, no, not the capitalized S, because the capitalized S is the one we talk about, which has two branches: differential statistics and differential statistics. When I say statistics, the small s, I'm referring to this the standard, these measures. I'm referring to the measures, okay, such as the S, standard deviation, or the X with a bar on top, the sample mean. Okay, so we use letters from the English alphabet just to distinguish the two. And you notice also, no, we use the small n for the sample size, and then capital N for the population size. Okay, I think I mentioned that to you a while ago. Okay, so why is this better than the range, no? Because here, class, you notice all the data values, no, are considered, no, are considered with reference to the mean. That's why in this one, it's the amount by which each individual value deviates from the mean. Unlike the range, you only consider the extreme values, no, the extreme values. Okay, and then it's not that detailed, no. It's not that detailed. Unlike this one, as in from each value from the mean, and from each other because of the divided by n minus 1 and divided by n. So it's not just simple as the distance between the data value and the mean. No, because we divide it and then we get the square root. Okay, so to understand this better, let's have an example. So again, no context, no unit, but again in actual setting, this has unit, no, and most probably it's not as simple as this. It can be a big data, no, big data. Okay, and it can be, for this one, it's ungrouped data, no, just like what we've been talking about in the first part. We can have ungroup here also, or group data, just like for the range, no, we can talk of the group and ungroup data. So this one is more of an ungroup data. So we have a formula for that, no? And then if you have a group data class, you also have another formula for that. Not this, a different formula. for the group data. Group data of big data, no? Group frequency distribution table of a big data. Okay, because this one is not big, no? Obviously. So we can just use this formula. Okay, but there's similarity for the formula also, because even though they have differences, but the principle is still the same, meaning whether it's a formula for the population or the formula for sample, still what we want is this, the amount by which individual deviates from the mean. Okay, so there's still similarity. Okay, since the formula has mean, you have to get the mean. So again, this is x sub I. So the formula for this for the sample mean, no? Sample mean of a ungroup data. So just add all of them divided by 5, you get 8. That's it. And then you take the difference, no? Each of this from the mean, or vice versa. Okay, that's why we have this table. This table here. Okay, these are the data values. So you subtract 2 minus 8 negative 6 square root, because that's what in the formula. And then where there's a bar here, class, there's a bar. And then 4 minus 8 is negative 4 square root 16. 7 minus 8 is negative 1 square root 1. 12 minus 8, 4 square root 16. 15 minus 8, 7 square root 49. The order does not matter, class. Now you can have your 8 minus 2, 6. Anyway, you will square it. So it doesn't really matter. No? And then add all of them, you get 118. That's why when you go back to the formula, to get the standard deviation, sample standard deviation, you just substitute. By the way, class, we use the formula for sample, not the population, because we assume this is a sample, no? But if you're dealing with the population, use the formula, no? Because there's a difference. This one is n minus 1. This is divided by, I'm sorry, this is divided by capital N. So there's a difference, no? And I have to remind you that sometimes even though it's a population, it's possible that you have the size is not that large, no? Possible to be also small. Okay, so it really depends on the nature of your population. Okay, but in general, when we talk of population, it deals with big data, Okay, so we use this because we assume that this is a sample. So we use the sample standard deviation. Okay, the formula for the sample standard deviation. So anyway, so we put the 118 here divided by 5 minus 1. In fact, I think it's in the next slide, the computation. So there. And then square root of this approximately equal to 5.43. Okay? 5.43. So if you have a large large standard deviation, that means your data are very spread. Your data values are very spread or dispersed from the mean and from each other in a way also, no? Okay, but if you have a large here, small, not that dispersed, no? They're not that dispersed from each other or from the mean. Okay, so now, what is the third one? The third one is related to this, no? Which is the variance. Actually, in the formula, you can already see, no? That it's related. And also the description. The variance is the square of the standard deviation. So meaning, if you go back to the formulas, just get the square. So if you square this, it's the same. You just get rid of the what? The radical sign or the square root, no? And then put 2 here. Then you get the formula for the sample variance and the population variance. And that's what we have here in this slide, right? That's what we have here in this slide. That's why, class, in the example, I just use the same example, no? Same example, no? That to emphasize that if you want to compute for the variance, same step as that of the computation of the, as in almost, no? Almost. The same steps as that of the computation of the standard deviation. In fact, the same table. The only difference is the last part, no? You don't get the square root. So the answer is 29.5. Whereas in the standard deviation, you get the square root because that's square root. Okay? That's why if you're in the problem, you're asked to get the standard deviation and variance, you don't have to repeat the process for the variance. All you have to do, square this, and you get 29.5. So I just showed you this again to emphasize what if the question is only asking for variance, no? Only asking for the variance. Okay, then you have to go through the steps again, the table and the formula, compute for the mean. Okay, Now, among the three, which one is the most frequently used? The most frequently used is the standard deviation. But there are times that it's better or best to use the range depending on the study. Just like what I mentioned in the first part, no? Or this variance is better or best among the three to use if you want to describe the variability, the spread, or the dispersion of your data, no? It depends again on the study. But among the three, it's the standard deviation. Okay, how come better to use standard than the variance? No, anyway, almost the same formula. If you'll notice, class, you're dealing with no, it's bigger, no, it's greater than the other one. That's not the only problem. The problem is also the unit, because you square this. So if the unit is meter, this will become square meters. Now, so in a variance, you deal with large units, unlike with the with the standard deviation, you're dealing with the small units. Okay, and in most of the studies, they use this, no? Standard deviation. The mean for the measures of central tendency, standard deviation for the measures of variation. And in fact, we can see that already here, no? In the formula of the standard deviation, so we have here the mean, which is the measure of central tendency. It's in the formula. And here we have the standard deviation. So in effect, we can see that they influence each other, no? Though we discuss them separately, part 1, part 2, part 3, but here we can already see, no, that they influence each other, no? The value, no, of the standard deviation is influenced by the value of the mean. Later class, in the third part, you will see also that all these three influence each other, no? In the third part. In fact, I showed to you already that one, right? The third part, which is the measures of relative position. So we're ready to discuss the third part, class. So again, just to reiterate, the measures of central tendency describe your data in terms of its center. The measures of variation describe your data in terms of the spread, the dispersion, or variability of your data. So the measures of relative position describe your data in terms of the position of your particular data value relative to the others, no? Relative to the other data values. That's why it's a measure of relative position. Now, what's the difference here, no? If in the two parts class, in the two measures, we're computing for a single value describing your whole data, right? Whereas in this one class, in this part, yes, we're also computing a single value, but only describing your one data value among your data. Did you see the difference? For the two parts, we're computing for a single value describing the whole data. That's why it's important that you have a measure which is influenced by all the data values, right? Because we're considering a single value representing the whole data. That is why in the measures of central tendency, the best is, or the most frequently used, is the mean, because we already saw there, or we already witnessed that the mean, that single value, which is the mean, is influenced by all the data values, right? By all the data values. And in part 2, the standard deviation is the best or the most frequently used, no? Because we noticed that single value is influenced by all the data values, no? By all the data value. And not only that, it's also influenced by a measure of central tendency, which is the mean. Okay, so that's what I mean by a single value describing the whole data. Whereas in this one class, it's not like that. You have a single value, data value, no? You have a single value here also, but only describing one data value, among your data values. Okay, I think that will become clearer to you when we discuss or when we give examples, no? So just like the two parts, we have three measures here. So we have the z-score, we have the percentile, we have the quartile. So let's discuss each of them and give examples and the difference among them, no? One from the other, no? What's the difference of one from the other? Okay, let's start with the z-score. The z-score for a given, this is what I'm trying to talk about. The z-score for a given data value x. So you're talking of a data value, just one data value among your data values. So if you're talking of n data values, for example, your sample size is n. Here we're just talking of one among the n. One among the n, no? not the whole n values, no? The n data values. No, we're talking of just one among the n data values, and let's represent it as x, no? So the z-score for a given data value x is the number of standard deviations s that x is above or below the mean of data. But by the way, class, this one we'll discuss this more in the next lesson, no? And you will appreciate this more, the use of this in the next lesson. For now, we can just have the simple interpretation, not the complete use, no? So that for now we can just focus on the computation and a little interpretation of it. Okay. In fact, the example is very simple, no? And the formula, right? And the formula. Look at this. So there. This mean class, we can replace this by what? By, since this is sample, by x bar. Because sometimes we can use the for the population z-score, where the z-score of a data coming from population. That's why you have to replace this by mu and this one by sigma, because you're talking of a z-score of a single value of a data value coming from a population. But this one we assume we're talking of what? Sample. That's why the mean here is the x bar, okay? Because in the next lesson class, we'll use a different formula, no? We'll have this as mu and this one is sigma, because we're talking of population there, no? In the next lesson. This one we're talking of sample. Okay? So you notice, it's simple, no context, but again in actual setting this has context. In fact, to the point that you really have to find the mean, no? You have a raw data, and then the raw data probably there's a need for you to group it, to put it in a table, no? And then you get the this one. Actually, again, in real setting, you don't compute it, you use a program. Okay? You use a program or software. In fact, yeah, you use a software or program. Okay, so which will give this to you. And in fact, it will not show you the computation anymore, right? Just the value like this, just like this. Okay, but again, you have to exert effort. Exert effort, a little effort only, by using that program, okay, right? By using that program, okay, but not really that you will compute it for by yourself, no? The program will be the one to do the computation and just give you the value, okay? And sometimes there's a program that will give you the analysis as well, no? The analysis, no? And then you'll be the one to use the analysis, how the analysis will be useful for your company or for you for that study that you're undertaking or conducting. Okay, so now this one is simple substitution, and we get this. So how do we interpret the 1.2? Now going back to the definition of the z-score, the number of standard deviations s that x is above or below the mean. So meaning to say, now this 950, which is not the whole data, just one of the data values in your sample probably, in the population probably, but in this case the example, so this is just one. How do you describe this? Based on the result, this 950 is 1.2 standard deviations above the mean. Above the mean because 950 is greater than the mean. But again, for now, maybe it's not that it's not that clear to you, this 1.2 standard deviations. But again, in the next lesson, it will become clearer. But for now, that's simple interpretation. Don't forget that, because we will use that again. That interpretation, which is the 950 is 1.2 standard deviations above the mean. Above the mean. Now, how about below the mean? If this is negative, then we say, but of course, we have a different data value. For example, we can have, okay, what is 950 minus 842? That's 108, right? 108. 108. Then I will subtract 842 so that I'll give an example of a data value which is less than the mean. So 842 minus 108. What's the answer? 700. Isn't it 700? What? 34, right? 34. So if I have x as 734 instead of 950 and substitute it here, so I will get what? I will get negative now, because 734 minus 842 is negative 108 divided by 90 is negative 1.2. So now to describe this this data value, this one data value, I will say this. No, 734 is 1.2. No need to mention the negative. 1.2 standard deviations below the mean. Okay, so I'll stop there. No, regarding the interpretation. No, you'll appreciate more of this in the next lesson. Okay, the use of the Z-score, and as in really very, very useful. No, once we discuss about the next lesson, you will see how useful this Z-score is. Okay, so next is what's the next measure? Percentile. So again, you notice single the data value, only one data value among the data values from your population or your sample. So we're talking of only one. Okay, the percentile score or the percentile of score X. This is the formula. The number of data values less than X, no, divided by total number of data values times 100. So you understand this better in the example. On a reading examination given to 900 students, Elaine's score of 602 was higher than the scores of 576 of the students who took the examination. What is the percentile for Elaine's score? So again, the score is 602, no? Because 900 and 576 are number of students, no? So we're talking of this. We want to describe this score, not the whole data, but just one of the data values, which is 602. What is the percentile of this? So that's why in the formula, we have to write here, percentile of score 602. And then we need to get the number of data values less than X. So meaning the number of students who get a score less than 602. And we have here 576. So we will put here 576 divided by the total number of students, no, or the examinees, which is 900 times 100. Because if you don't multiply it by 100, you get decimal, no? But we want 100 because we're talking of percent. I'm sorry. We're talking of percent. Okay, that's why you multiply it by 100. Okay, so this is the way to compute it. So now the Ellen score, which is the 602, places her at the 64th percentile. So that's how we describe this data value, this particular data value. 64th percentile, or simply 64%, no? But usually percentile, we put it percentile. Okay, so usually in the entrance examination, this is being used, no? This is being used. And the importance of this class, putting it in percent form, this percentile, is because this 900 may change, no? Possible that instead of 900, we're talking of 1,000, no? 1,000 students. 1,000 students. So if your score is 64th percentile, meaning this will change, no? This will change. 640, right? 640, meaning your score is higher than the scores of the 640 students. Not anymore 576 because you have different population size or sample size, no? Then times 100, but the answer is just the same. So that's the importance of having a percent in a percentile, percent form in a percentile, because at least you know, no? You know that your performance with respect to the whole population, regardless of the size, okay? And you know that you can just say in general that you perform well, no? That your score is higher than those 64%. You can just think of it that way. 64% of the total number of examinees, no? You can just think of it that way. However, class, the problem with the percentile is what? It does not give you the raw score. Okay, and it may give you a wrong interpretation of your performance. Now that's the problem with the percentile, no? Why? Because it's not the raw score. Because it's possible that, for example, the total is 300, no? I'm sorry. The total items 300. But possible that your percentile is, let us say, 90th percentile, but your score is 100 only. 100 only. But you know that if it's 100, it's very low, right? But your percentile is high. Okay, because it only tells you your performance. Of the 90%, the 90% of the total number of students, you get a score higher than the 90%. But your score is 100. So that means the score of the 90% is lower than 100. So the performance of the whole population is really not good. If you look at the raw score, no? So the only problem with the percentile is the misled, no, interpretation. Okay, but of course, in a real setting, I don't think you will pass if you get 100. No, it has to be like above 50%, or if not 70%. No, 70%. So in a way, I think it is impossible for this to happen. No? You get 100 and yet 90 percentile. But I'm just saying to emphasize the point that this is not related to your raw score. It's not related to your raw score. It's just related to your, that's why relative position. Your position relative to the others, no? To the performance of the others. In particular, the 64% of the whole population. You perform better than the 64%. So meaning you're in the above 36%, no? 36% of the whole population. In the ranking, no? In the ranking. Okay. Okay, class. I think that's clear regarding the percentile. That's why, in a way, class, between the two, but of course, it depends on the study. No? There are studies that this one is better to use percentile than the z-score. Okay. But for now, I cannot tell. If z-score is the most frequently used among the three. No, among the three. Why? Because as I mentioned, in this measures of relative position, you're not considering the whole data. No? You're only considering a single data value, one data value, comparing the position with the others, no? With the others. Okay, so probably they're equally important or equally used. I'm not really sure about that, but anyway, but later I will see the use of this one, the z-score. And find out yourself, no, whether this one is the most frequently used or the most useful among the three. Okay, among the three. So let me leave it as a hanging question. Okay, for now. Probably in the next lesson, I'll comment on that. Okay, for now, maybe that will be your homework or activity. So among these three, no. So what's the third one? Because so far we've discussed the two. So the third one is the quartile. No? So actually quartiles. Now, quartile partition a ranked data set into 4 equal groups. No? 4 equal groups. Okay, so this one class is percentile. No? In a way, 100. No? You're considering 100. No? Actually, this one is also 100%. It's just that into 4 equal. Into 4 equal. Whereas here, class, it's more of like 100 parts. No? Because we can talk of not only 64, we can have 50, 51, 52 percentiles. So in a way, it's more of 100 parts, no? 100 parts, whereas here, 4 equal groups, no? So Q1 covers 25%. Q2 is the median because it covers the 50%. Q3 covers the 75%. Okay? So let's have an example, no? To understand this better. An example. Again, a simple example and no context, no unit. Just to focus on the computation. But again, in actual setting, this has units. No? It has context. Okay, class? And usually it's a big data, not as small as this. Okay? Just to illustrate how to how to get the median, I mean the Q2, the Q1, the Q3. Now, since Q2 is median, it's the same, the same way, no? The same way. On how to get the median to get the Q2, no? To get the Q2 is the same way as getting the median. So now rank data, so arrange this from lowest to highest. So we have 7, so it's odd. So 7 divided by 2 is 3.5. So the fourth is 40, that's your median. Now to get the Q1, it's also median, no? Median of the data values less than the median or less than the Q2. So only this 3. So what's the median? It's 32. That's why that's your Q1 for the whole. But for the 3, it's a median. No? It's 32 is a median, but we're talking of the whole. That's why Q1. Now, I think you know already what to do with Q3. No? You get the median of those data values greater than 40. So since we only have 3, so of course the median is 43. So if you talk of the whole thing, the whole data, 43 is the Q3. Okay? Actually, class, we can relate this no, to percentile. No? So we can say that the Q1 is actually the P25, no? The 25th the 25th percentile. We can denote it as like this, no? The percentile P. You can use P25. Actually, in other references, instead of this, Q sub 1, no? Q sub 2, Q sub 3. So anyway, it's just a notation. So the median class, I think you know already, B50, 50th percentile. And then the Q3 is the P75. Okay, they're just the same thing, no? The same thing. So if you look at the so we can say this percentile of score 602 is actually the P64, no? Okay. Meaning the 602. So I'm talking about the 602. So the 602 is this one. Okay, not the percentile of This 602 is the 64th percentile. Okay? So we can use this notation. So again, just like in part 1, part 2, we can talk of group data. We can talk of group data also. We have a formula also for this, for group data. Also for this one. Okay? For the quartile, no? For the Z-score class, we don't relate this usually to a group data, no? Not usually to a group data. More of the distribution, no? That's why in the next lesson you understand this better and the use of this, no? Because we relate this more on the distribution of data, the distribution of your data. Okay, so I'll talk more about that in the next lesson and relate this to that, no? The distribution of data. Okay, class. So now I think I think these are the these are just the website references from your module, no? But now I would like to show to you the website, which is another reference, so that I can talk about the group data, no? So let me show you that website. Okay, this one. So this one, let me show you first the reference for copyright. So, and if you want to refer again to this one, it's the Math is Fun. Okay, you can keep a screenshot of this. Okay, so let's talk about the group data, the formula. Okay, so we have this data values. But if you notice, it's not also big, you know, it's just 21. But again, greater than the examples we had in the PowerPoint. So this one's 21. But again, this is not big data. And then if you use the formulas that we discussed for the ungrouped data, so yeah, you'll just get this. The median. Okay, so we get 61. For the mean, 61 point. And then the mode, again, rank data, 62. So we have a unimodal data. Now, how about if you put this in a table? So that's where we get a group frequency distribution table. I will discuss this more in the next lesson. However, I'll just help you to recall how to create this table, but not in detail. Not in detail. Okay, so let me just discuss a little about this, and then more, but not in detail, next lesson. How come 2? Because you have between 51 to 55, you can see 2 values there, here, 51 to 55. So you have 53 and 55. So that's why 2. The number of data values within this interval, data values, we have 2 from our raw data. These are raw data and group, because it's not arranged in a table. In fact, it's not even arranged from highest to from lowest to highest. Okay, so that's the meaning, class. That's the meaning of the 2 here. Then 56 to 60, we have 7 there. Data values 56 to 60. So we have here 1, right? 1, 2, Okay, and so on. So I'll leave that part to you. Anyway, that's what it means by the frequency. That's why if you add all this 21, because 9 plus 8, 17 plus 4, 21, because you only count here from the raw data. So you have 21. Okay. So what do you notice, class? If you apply the formulas for the group ungrouped data that we discussed in the PowerPoint presentation, you get the exact mean, exact median, exact mode. But if we apply the formulas for the group data, we only get estimate. Let me show you. Approximate. For example, this one, estimating the mean from group data. So the formula is this. We have a formula. So there, estimated mean. So you notice it's different from the actual mean, right? This one is 61.33, but the actual mean is 61.38. No, that's the exact. Actually, and so on, right? Non-terminating decimal number. So there's a formula based on the table, no? On the table. So how do you do it? You get the midpoint, and the frequency. Now, how do you get the midpoint? Just add this. 51 plus 55 is 106, right? Divided by 2, 53. That's why you get 53 here, 53. And then multiply. 53 times 2, 106, and so on. And then add all of them. So there's similarity, right? Similarity. But the problem is, I think you know already why we only got estimated, because we only get the midpoint. We don't consider the exact data values, but the midpoint of the class interval, or the class, we call them the classes now, or the class intervals. That's why estimated. But if you'll notice, close, right? It's close. It's close enough. Okay, it's close enough. But later, I'll show to you a program, which is Excel, on how to get the mean without using the formula for the group data or ungrouped data. But the nice thing with the program, we will get the exact mean, and less effort. No, but again, important that you know this so that you can appreciate the software or the technology, no? The technology. Okay, class. So how about for the median, estimating the median from the group data? Again, we have a formula, but again, estimated, no? There, you notice the formula. It's not nice, no? The formula. There are a lot of variables in the formula. But the problem also is you don't get the exact, you only get the estimated, no? So what's the estimated? 61.43. But we know the exact is 61, right? That's what it mentioned here a while ago. So the group data useful only, the formulas for the group data useful only if you're dealing with big data, and also if you'll do it manually. If the software, if you don't have the software, no, you don't have the software, because sometimes you have to buy the software, no, you have to buy. But if it's free, then why do you have to do it manually? Then just use the software, no. That's the use of the formulas for group data. If you cannot avail of the software because you still have to buy it because probably expensive, then you do it manually, no. So what's the median? 61, no? 61. So in a way, it's kind of close, no? It's kind of close. So the use of that formula, formulas for the group data, yeah, can be useful also for big data if the software is not available. Because if you have big data and no software is available, it's difficult to use. It's difficult to use the formulas for the ungrouped data, data. Anyway, class, this one is 21, right? 21. Usually, if you want to create a table, better if it's like 30 and above, no? Usually, that's the convention, no? If you have number of data values or sample size or population size greater than 30. I think this one is for illustration, no? That's why even if it's just 21, for illustration, we put it in a table, no? But again, it's not practical because we want the exact, so better to use the formulas for the ungrouped data. Anyway, they're just few, no? 21 is still few. Actually, even 30 is still few, no? It's just that by convention, among the statisticians, for 30, it's all right, something like that. But again, it's still okay to you. You can do it manually, no? Using the formulas for the ungrouped data. Okay, how about the mode? The mode is fun, funny, no? Because you will get, look at the formula for the mode. Where is that? Okay, this for the mode, this one. But you know how to get the mode, right? Look at the formula. So you notice it's complicated. But again, even though that's why, class, it's complicated. But I will not discuss this, will not discuss. But the thing here is that what we get is just estimated, not the exact, because the actual mode is not 61.5, but it's close enough. So fair enough, because it's close enough. But the actual mode is, I guess, 62. Is that 62 a while ago? Yeah, 62, no? But it's close enough, no? 61.5 is close enough. Okay, so now let me show you how to use the Excel file, no? But of course, I will not for all measures, just for some, no, for some. Okay, for some measures. Yeah, 61.5. Okay, let me go now to the what is this? For the other class, you can research on that, the formulas for the group data when you talk of measures of variation and measures of relative position. We also have formulas for those. No? So if you want, you can explore more on. You can Google. No? But again, if you have the program, just use the program. Okay. But to appreciate the program, I suggest you also try to experience the computational part or the manual part in the computation of these measures. Okay, so let me go now to the Excel, and let me go back to the PowerPoint. Okay, first the mean class, the mean. I think some of you, or if not all of you, know this already, know how to do the Excel file. And then later class, you can explore your Excel file, no? Because I will not discuss all of this. I'll give example. For example, for the mean class. So we have this data, 92. So we can input that. 92, 84. No? So if I were you class, if you have the Excel file, you can follow with me, together with me. You can follow what I'm doing. 92, 84, 65. It's because you learn better by doing. 92, 84, 65, 76, 88, no? 76, 88, and then what? 90. So 90. So it's simple as this, no? Equals, and then formula, and then insert function, then average. Average is the mean here, and then insert function. So that's it. This time you don't have to write it now because it's already highlighted, meaning all these are considered in the formula. All these data values will be considered. But if you will write it, class, you just write it simply as A2 colon A7. That's it. You don't really have to write A2, A3, no. It's like the colons like ellipsis, no, dot, 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 no. A2 up to A7, no? And then you click it or done here, or enter here, or click done. Then that's it. Isn't it the same answer, 82.5? Right? The same answer, no? 82.5. Now, how about the standard deviation? This is for the measure of measure of central tendency. For the measure of variation, let's try the standard deviation. Standard deviation. So this one, I'll input this in the Excel file. So we have 2, 4, 7, 12, 7, 12, 15. Okay, so there, 2, 4, 7, 12, 15. And then I'll put the answer here, equals, but I can put the answer here if I want to, but okay, so that's a problem. So I want to put it here so that align with the mean, no? Is equal to, again, insert function. I think we have it here already, standard deviation. So standard, we have a lot here. That's why you can explore this more later, no? Explore this more. Okay. So I don't think we have here Z-score. I haven't really used all of this yet, no? So I'm not so sure if we have Z-score here. We have the Z-test, no? This one is different. The Z-test. Okay, so anyway, so standard deviation. So there, standard deviation. So there. But you notice A8. But what we want is B. So you have to write it. No? The values that we want is in the column B. So B, B2, B2. You know, it's correct because it's highlighted. So B2 up to B6. No? Colon B6. Okay, that's it. So you know, these are the data values that you want in the formula. So it's highlighted. So you can enter now or done. And there, you get the same answer. No? In fact, it's more exact. No? 5.43. It's the same thing, right? It's the same thing, 5.43. Okay, class? Now, I want you to try to find other program other than this and explore this. No? You try to, if you can find the other measures. No? And the following lessons also, probably we will use this again, or the other programs. For example, the SPSS. But the problem with the SPSS class, you have to buy it. No? It's licensed. No? But there's a similar one, which is PSPP. I think that one is free download. You can Google it. So again, the licensed one, but unless you have someone, you know someone who can share it with you, SPSS. So the other one is just change S to P and the P to S. No? We have PSPP. The PSPP, similar, not similar to SPSS, but not just similar, but not exactly the same. No? Exactly the same. But we can use this. No? You can use it for practice. No? That program. And it's more complete than the Excel. No? When you want to explore on the statistical functions, no, that one is more complete than the Excel. Okay, so I think I will stop there, class, because it's almost lunch time also. So let me go back to the PowerPoint. Okay, so I'll see you on the by the way, did I show you the did I show you? I think I showed to you, right? Let me show to you for copyright. I think I already showed it to you, right? This one, the website. Okay, just to be sure, no. So this is the website. So I like to reiterate, no, the reference. And for the others, yeah, just from your module, no. Okay, so I'll just see you on the next lesson, class, no, related to this, to some part. Actually, related to this, no. Related can be implicitly or explicitly related, no, to this lesson, the next lesson. Okay, class. So that ends the lesson for this week. Thank you very much for attending.